Okay, so this is the calculations video for the antacids experiment, and this should look fairly similar to what you guys have. You have the starting, you have the ideal, very pale pink color, and a bright pink over titration color. You can see the difference between starting and ideal, but again, in lab, it's a little difficult to see. We went ahead and provided what the antacid was in its active ingredients, and these active ingredients will actually come into play in one of the post-lab questions that I'll explain at the end. So first and foremost, it looks like there's lots and lots of data tables and lots of stuff to find. Again, a lot of this is broken down just to do one piece at a time, so don't stress. We're going to walk through all of it step by step. There we go. So measured values, we have the mass of the antacid tablet, the volume of HCl we added, the initial and final volumes on the burette. So the volume delivered, it's very straightforward. It's just final minus initial. In this experiment, we don't have any averages or anything, so I'll just be doing the calculations for the example data, which should match all of the typed out calculations you have in the lab data itself as well. So we get 9.17 milliliters of NaOH. Very easy, very straightforward. As for significant figures, again, 2 decimal points, 2 decimal points, 2 decimal points. Everything already works out as we need it to. So go ahead and clear this so I can move down. Gotta remember to, there we go. Okay. So volume of HCl, that's one of the values we have written down up above. Again, it's just to walk through each individual piece. There's not necessarily all of these things to calculate. The molarity of HCl was provided on the bottle as 0.1000. Moles of HCl added. So this whole table is just to get you to moles of HCl added at the beginning of the experiment. So we thought by breaking it down into a bunch of different tables, it would be easier to, that looks really bad. It would be easier to deal with. So to get to moles, we'll need the molarity, but the molarity is in moles per liter. So we need to convert milliliters to liters. And then we can use the molarity to find the moles of HCl. Again, these are the moles added at the very beginning of the reaction, before we add the antacid, before we do anything else. There we go. So we get 0.00499 moles of HCl. 3 significant figures, metric conversion. This has 4 significant figures, so our answer will be rounded to 3, and it already has those 3. So we don't even need to worry about changing anything for significant figures either. Okay, so we've gotten that one. Let's clear those and scroll down. So now we're trying to find the moles of NaOH titrated. So the volume delivered of NaOH is what we found up above, 9.17. And we're doing basically the same mathematical calculation, just with different values of different chemicals. Trying to do dots is difficult. Again, we'll need the volume in liters and then the molarity of NaOH that was provided to us. In this case, it's also 0.1. A lot of the volumes we used last week, or a lot of the concentrations we used last week were 0.1. That's honestly just because it's an easy amount to make. But whatever is on the bottle is the number that you'll need. It won't always be 0.1. Zero point 0.0000917. As always, we should check our significant figures. This has 3, and it's a metric conversion that has 4, and ours already has 3, so we don't need to do anything there again. Okay. So now is where they start getting a little more complicated. We want to figure out the moles of base in the antacid. So the moles of NaOH titrated is what we just found up here. And the moles of HCl added to the antacid is what we found up here, 0.004. So the moles of HCl consumed in the titration is the next thing to figure out. Let's go down here where I have some room. So we know how much NaOH we added, or at least the moles of NaOH we added. And all of those moles of NaOH reacted with moles of HCl. So if we have the chemical equation for that reaction, we can use the molar coefficients to convert from one to the next. So there's no coefficient in front of NaOH or HCl, so this is a 1-to-1 reaction. Again, you may notice that a lot of our reactions are 1-to-1. That's just because they're easier. The math is easier. Some of the more complicated reactions that have different coefficients sometimes use more dangerous chemicals. And we get, in this case, 0.000917 moles of HCl consumed in our titration. So if we think about this for a minute, let me clear these. If you look back at the slides, there's a picture. So we had some HCl. And to that, we added the antacid, that powder. So we have some moles of HCl here that we calculated. I'll put a number sign in front of it, calculate that. And we have some unknown moles of base in our antacid. What we end up with is our solution, and all of the antacid is consumed. That's why this is a back titration. We have some moles of base and we way overshoot that. So we have less moles of HCl now. So we don't know how many, but we know we have less. Then when we do the titration with NaOH, we know the moles of NaOH we added. That's one of the values we just calculated. And when we're done with all of that, we end up with something neutral, meaning there's basically no HCl or NaOH left. Realistically, there's probably a very, very, very small amount, but that's negligible that we don't need to be concerned with. So if we know this, we can find this. That was the moles of HCl consumed in our titration that we just found. So now we do know this value. If we know how much we had before adding the antacid and how much we have left over after adding the antacid, then we can figure out how much the antacid removed. And that's what we're looking for next. That's this. The moles of HCl consumed by the antacid is how much HCl was removed. So that's just going to be the difference of what we had before. And what we had after. So we're doing subtraction 1, 2, 3, 4, 5 decimal points. 1, 2, 3, 4, 5, 6 decimal points. So we need to round our answer to 5. 2, 3, 4, 5. We'll round after that 7. Let me move that. So that 3 will round down. Now, what we really care about is the moles of base in the antacid. And so originally, we don't know what's in the antacid. And so where this experiment originally came from, the lab manual said, just assume it's another 1-to-1 reaction. So they had us use this equation. If we assume it's 1-to-1, then we can do the same thing with 0.00407. I'm going to put this 3 in parentheses just to show that it's part of the number, but significant. So you could call it a guard digit. But that way my mathematical answer will be correct, and then I can round it as needed. So they want us to just assume it's a 1-to-1 reaction with nothing written in front of either of those and get .0.004073 moles of base in the antacid. This has 3 significant figures. This we don't care about. So this needs to be rounded to 3 significant figures after that 7 as well. Okay. So one of your post-lab questions does ask, since we do know afterwards what the reaction is. And in this case, it's 2 to 1. How does that change things? And so what you would have to do is figure out the new chemical reaction. And what you find out is in that new one, there's still a 1 in front of the base, the calcium carbonate, magnesium hydroxide, I believe. But now there's a 2 in front of the HCl for what it makes. So that would change this number to a 2 and actually make that number half as big. And so make sure you can kind of manipulate these equations and know how that affects your end results. So we now have our moles of base in the antacid. But if you remember back from the video, that was a powder, it was ground up, it was part of an antacid tablet. We want to figure out what's in the entire antacid tablet, but they vary a little bit in the exact moles because their size varies. So going all the way back to density and independent and dependent properties. Moles is an amount. So as you have more of it, you will have more moles. But if we divide our moles by the mass of our antacid, we will get a ratio that should be pretty constant across all of our antacids. So the mass of the antacid that we found up here is 0.31 grams. And that's one of our measured values. So now we can find the moles per gram, which should hopefully be pretty constant across all of our samples. Again, I remember that there was a 3 there, so I'm going to use it as a guard digit. And get 0.013138707 moles per gram. This has 3 significant figures. Again, this 3 doesn't count, and so I put it in parentheses. This has 2 significant figures. So that's what we're going to round our answer to. And it'll round to 0.013 moles of base per gram of antacid. So that's really all of the calculations. You can repeat it for all of your other trials and get all of your values. There should be an extra credit assignment as well that does something a little bit different. It looks at a full sample of antacid and has you find the moles of base in 1 tablet of antacid instead of per gram. But a lot of the math is very similar and very straightforward, similar to this. So again, all of this should be typed out in your lab data as well as in this video. You've got some examples. If you run into questions, please let me know. And otherwise, hopefully this all goes well. There we go. Maybe. There we go. There we go.